Hi guys, welcome back. We are going to look at plumbing further. I am your facilitator for today, Mr. Khan from Umgungundlovu TVET College in Pietermaritzburg. We're going to look at report 191, plumbing theory N1. If you can recall, we started with drainage, module 7. We stopped at septic tanks, French drains. Today we're going to look further into what we call vacuum or conservancy tanks, the purposes of traps, a one-pipe sewage system, sub-stack sewage system, duties of a sanitation inspector. Let us go forward. What is a conservancy or vacuum tank? If you can recall, in our previous session, we spoke about a septic tank, and a septic tank was used in areas where we have no municipality that drains out your sewage or it goes into a sewage farm. From the septic tank, we discussed a French drain. The French drain was designed in order to facilitate farmers that do not have access for trucks to drain out the septic tank. Now we're going to look at a vacuum or conservancy tank that was designed or has been designed for those people that do not have access to their property while they are away. So in other words, me and you are gone to work. We need our drain to be emptied, but there's no one at home. How does that happen? So let's look at how a conservancy tank works in the first place. Okay, I did explain to you where there's no access to the premises for a truck to get in. Your tank is built close to your boundary wall, in other words, in your property, leading out of your property. We will do a simple sketch to explain that further. Okay, all tanks are built with a slope. We use 110 millimeter pipes to lead from the pipe out of your property. Your honeysuckle truck is parked on the roadside, drains it and removes your waste product. Okay. Now we'll draw a simple diagram to illustrate to you how a vacuum tank works. Once again, people, we're not to scale, and let's go. We understand how a septic tank works, how a French drain works. A conservancy tank is the same principle as a septic tank. In other words, it's a holding tank for sewage. But in this case, it's a single tank. It's a single tank. This tank is built on a slope or sloping. As we can see, there's a slope. Right? This is built in your property. Your boundary wall is here. Boundary wall, boundary fence, whatever you want to call it, that's your boundary. That's where your property stops. That's it. Then we have the pavement, and then we have a road. That is the road. Okay. So what happens here is all your effluents again. Concrete top, manhole cover, must have ventilation for fresh air to come in, decomposition to take place, biodegrading to take place. From here, what happens is that, let me just do this at more of angle so you can see it properly. There we go. Your walls again. 220 millimeters, waterproof. Your floor concrete and is sloped. Okay. Again, 110 mm pipe coming into the tank with a T-piece. Right? Effluents from our house or sewage coming in. This is your sewer from the house. Everything starts settling at the bottom and rising. Okay. Manhole is there in the event we need to throw in some chemicals to aid the decomposition. From here, we have a pipe that leads out of the property. Remember, this tank is in your property. This is in-house. This is in the street. Okay. So what happens here? Sloping ground, pipe slows out, goes to a gate valve, which is covered by a manual cover. This is in your pavement. Pavement. Okay. So what happens here? Once my tank is full, normally this happens after 3 months. Every 3 months the council will send a truck out to drain it out and they bill it for you separately. What happens here is the truck will normally park on the street. Your truck parks here. You will take a pipe into that gate valve, connect it up. He pumps all this. Because it's at a slope, your sewage flows downward. It will flow downward into the truck and they will transport that to the sewage farm. That is what we call a conservancy or septic tank, conservancy or vacuum tank. Remember, it's a single tank. Single tank, unlike our septic tank was 2 tanks, this is a single tank. Has a slope going away from your boundary, out of your property, to a gate valve. Once that gate valve is open, it pushes all this waste up to the aid of a pump into a truck. We can draw some wheels to make it more interesting for those of us that don't know what a truck looks like. That's a truck. So the guys will drain it and it's gone. Okay, so that is a conservancy or vacuum tank. That's simple principle, that's how it works, people. We will move further. Okay, we've covered how it works and what happens to it. On your screen in front of you, you can see a simple sketch of a conservancy tank. Like I explained to you earlier on, we have the tank built on. It has a slope towards the street. We have a gate valve. The gate valve is covered with a manual cover. You have your boundary wall. All your effluence leads out of the street to the gate valve and is stopped by the gate valve. Once we need to drain, your truck will park on the street. Your pipe will be connected to your gate valve and your effluents will be removed. This is your conservancy tank. Example was done on the board. Example is in front of you. Right, now we're going to look at a trap. What is a trap, people? What is a trap? A trap is a fitting or part of a sanitary fitting that is designed to retain water. The most common example of a trap is a water closet at home, your toilet at home. And in that water closet, no matter how many times we flush, there is still water in the pan. And the reason for that is because that is what we call a trap. It is shaped in a P. It is shaped in a P. Illustration of a P, and if you look at our water closet goes like that. So what happens here is the water is always filled in here, always water. When we flush, this water pushes out and comes out, but because it's shaped in a P shape, there's always water in there. That helps us in order for bad, foul smells not to come back to our sewage. So it acts as a trap. Water is the hardest substance known to man. A survey was done where they took a .22 caliber gun, fired it into a bucket of water. It did not penetrate to the bottom of the water. So in other words, the bucket did not get damaged because of the hardness of the water. Okay, so traps are designed to provide a water seal. Requirements of a trap. In order for a trap to work effectively, there are certain requirements. It should be self-cleaning. Once again, we come back to the toilet. Every time we flush, it cleans out water. Clean water comes in. We flush, cleans out water. Even your basin. If you notice under your basin, you'll see a trap as well. Every time you open the water, the trap cleans itself, so it's self-cleaning. Your interior surfaces must be smooth. Reason being, we don't want anything to get stuck onto it and create a blockage. It must be stable or firm. If it is not stable, it's going to give us problems. It must be watertight. That is self-explanatory. If it's not watertight, we're going to have leaks. Which brings us to our next topic for discussion, which is called a one-pipe system. But before we go forward to a one-pipe system, let me explain to you a few of the traps that we have. We have certain types which is called an S trap, a P trap, which is the most common used. Now, like I explained to you, the P trap takes the shape of a P, That is the letter P. Okay? But remember, in our area of expertise, we turn it around. So our trap is turned around in that shape. This is typically used under our basins where our sewage is leading out of the wall. So what happens here? Water fills in here up to that level. So there's always water in here. Okay. Then we have what we call is the S trap. The S trap. That's an S. But we use it upside down. Going like that. Once again here. What happens here? These are used in areas where the pipe is going underground. So the pipe is going underground. S trap. P trap goes through the wall. S trap goes underground. Again, water will be filled up here, creating a seal. Those are the two most common traps that we get. It is called S trap and P trap. We have traps in our basins, in our baths, in our sinks, in our showers, in our water closet. Almost every single item that we use in our house, be it a sanitary fixture, be it a waste fixture, must have a trap. Must have a trap. Okay, going back again, we said we're discussing a one-pipe sewage system. What is a one-pipe sewage system, people? We've seen this, and we see it every day. It's the most common system that is used in our property. The advantages of a one-pipe system is that we have fewer connections that lead underground. We need fewer vent pipes. Your arrangement of pipes are straight and simple. Your labor cost is cheaper. One gully is required for a building. Your disadvantages. If it is not done properly, it can lead to backups and blockages. Too many water closets or toilets connected to it could damage the seal if it is rapidly flushed. So in other words, you've got 4 or 5 toilets and each one is flushed simultaneously, and very often it damages water seals. Okay? You need larger size of pipes. Now that we understand the advantages and the disadvantages of a one-pipe system, let's do a simple illustration to show us how it works practically. One-pipe system. Okay. Typically, we use a one-pipe system in a flat. So we have different floors on the flat. Let's take a building that has 4 floors. Okay? We can say this is the first floor. That is the second floor, your third, and your fourth. Okay. Now on each floor is divided into flats. And each flat has what? The following: a common bathroom and a common kitchen. And how is it done? We'll draw a line coming down. We will have a bathroom. Water closet will have a bath. We'll have a basin. We'll have a kitchen. Kitchen will have your sink. Okay, that one is the norm for every floor. So we'll have again kitchen here. We'll have the bath, basin, water closet. This is the norm that it will fall on every floor. So again, it will fall again. Bath, basin, kitchen. Bath, basin, kitchen. So on each floor we'll have the similar item. I will quickly place it in. Remember once again guys, this is an idea of how it will look. And remember, planning is the most important. Planning, planning, planning. Correct planning leads to less confusion on site. Okay, so we've got on each floor our water closet, our bath, our basin. That complements one bathroom, our kitchen. Now what normally happens is we have what we call a one-pipe system. The one-pipe system was designed to meet up and join council. This is your main sewer. This is laid by the council. If you look at our houses as well, we use what is called a one-pipe system or a subsect system. We will discuss that just now. Okay, so what happens here is our water closet fits in with a 110 mm pipe. This pipe here is 110 millimeters as well. Your main pipe is 110 millimeters. Your water closet 110 millimeters. Why? Because we need to ensure that the excreta, the toilet paper, all that is flushed down. Your bath, your basin, your kitchen is 50 millimeter. Okay. So all these pipes are joined at an angle, as you can see, sloping towards the main pipe coming down. This is called a one pipe system where all your water closet, your bath, your basin, your kitchen all leads into one common sewer. Okay. So that will happen with the next floor as well. Going down, bath, basin, kitchen, water closet, bath, basin, kitchen, water closet, bath, basin, kitchen, and that's one side done. The following side comes in again. Water closet, down, water closet, down, water closet, down, water closet, down. Again, bath, basin, bath, basin, bath, basin, kitchen, 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 kitchen coming in. Now we said this pipe is 110 millimeters. These pipes here are 50 millimeters. Okay, all coming down joined to one common sewer. This is the main sewer which the council provides us with. Okay. Now note here we have no ventilation here, no ventilation. So we have to create the ventilation. This 110 mm pipe normally goes out of the roof. So the roof of the building will come up. That way it goes out of the roof. Okay, let's just restructure that, people, so we don't confuse ourselves. That's the roof. Okay. So commonly what happens here is we join a pipe at an angle going up to the 110 mm vent pipe. This becomes the vent pipe. Why? Because this pipe is open on the roof, allowing all the fumes and that to escape from there. Simple structure. The same thing would happen to the next one. Comes up, it will join here. It will come up again, it will join there. Come up again, it will join. So each floor of flats or each block of flats, if you look at it, is venting to one common vent pipe. This vent pipe on the top looks something similar to this here. 110 mm pipe. It has a cap on it. Okay, has a cap on it. Inside here we will normally place some wire, or they put a vent on this here. So only air is allowed into this pipe here. Only air is allowed into this here. It flows right through, so there is no contamination of the water. On your left hand side as well, the same thing would apply. Venting, 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 venting. So this is what we call a one pipe system, where everything leads to one common drain going out to your main council supply. Everything is vented to one pipe. Our venting is there. Your vent pipe is there. It leads out, it's contracted. It is suitable and stable. To recap very quickly, people, the one pipe system. All our pipes lead into one common sewer. One common sewer coming down. Everything, all our appliances get connected to one pipe leading to one drain. We have all this vented to one system. Vent pipe looks something like that with a vent cap on the top. Okay. Now we're going to look at what we call a one stack or a sub-stack system. Sub-stack system, the same principle as how we have our one pipe system. The advantages of that, it reduces labor cost, materials cost is reduced. Your disadvantages, your vent valves that we have are subject to vandalism. Unwanted cells can escape if the valves are not correctly placed. In front of you, you can see, when I spoke about the valve on the top of the roof, the valve on top of the roof is similar to this here. Similar valve that we have here is what you'll find on your roof structure. Here we can see this is 110 mm reduced by 50 millimeters. Now that we understand what a one pipe system is, how a vent valve looks, we're going to look at some of the duties of a sanitation inspector. Remember, that person is working for the municipality or council. He's responsible or she is responsible for coming out and checking that work is done according to plan, according to building regulations. They need to check and approve plans. They need to inspect your work once it's completed. They need to check for soundness and leak because we don't want accidents. Accidents can cost lives. Lives are very expensive. A life cannot be replaced. What we do is, what the first test they do is what we call a preliminary test or an open test. This is when your trench is open. In the open position, once you dig your trench, you will call the inspector in. He will come and check that the drain is laid according to plan, that your drain has to be a straight line. In our previous session, we spoke about straight line of a drain. We spoke about ventilation and those type of things. So he's coming to check what you've done. If it's done correctly, you have sufficient access and inspection. All pipes are encased if they not meet the minimum depth. Now in South Africa, your minimum depth for your pipe is 500 millimeters. So in other words, all your sewage pipe must be minimum of 500 millimeters below the ground before it's encased. If anything is less than 500 millimeters, we have to encase it in concrete, which means that we have to place concrete over the pipe. So we have example, this here is the pipe. We encase it over in concrete, so anything that hits that will not damage the pipe. You have the proper gradient or the fall. Your pipes have ventilation. In front of us, we can see an example of an open trench where the inspector will come and check for straightness of the trench, gradient of the trench, and everything falls under specifications. Then he does what is called the final test or the closing test. Once you lay your pipe in, he will check that your bore is correct. He will check that there's no leaks on your pipe. He does it in different ways. He shines a torch in to see if it's in the correct place. We place a mirror on one side, a torch on the other side. He sees for reflections to see if your pipes are straight. Okay. He checks if there are any leaks. To check for leaks, we use different tests as well. In front of you, you can see an example of a close or final test where we see the pipe now has been finally closed with soil, aggregates to cover it up. Okay. We do certain types of tests. Most common test we do is a compressed air test where we introduce air into the system. If air escapes in the joints, we know there's a leak. We do what is called a smoke test where a smoke machine is used. Smoke is introduced into the pipes. If the smoke escapes, there's a leak. And with the preferred method is a water test. Water test can only be done on dry weather conditions. Water is placed into the pipe. If the water escapes at the joints, we know there's a leak and it needs to be repaired. Examples of a smoke test, as we can see, the inspector is standing on one end. Smoke machine is placed into the sewer line, introduction of smoke, it escapes on the other end, which is an opening. If in between there's a leak, we know there's a problem. Another example of a smoke test, smoke is introduced into the manhole. We can see there's a crack here on the pipe. that leads out into the road surfaces and smoke escapes. Therefore, we know exactly where the leak is and we can work with that area, not working with the entire area. This brings us to the end of the session. I trust and I hope that it was worth your while and you've learned from it. With that, I bid you a farewell until we meet again. Keep safe. Thank you.